All right, so we're starting on assignment number 32 with double angles. So let me give you the formula for the double angles in this blank space over here. Okay, so the double angle formulas, I took a look and I believe it's only sine and cosine, so I'll just give you the sine and cosine double angle formulas. Make sure you write these down. Angle, double angle formulas. Okay, so we have sine of 2 theta. That's a theta. Remember theta, it looks like a 0 with a line through it. Theta. So sine of 2 theta is equal to 2 sine theta cosine theta. And then we also have cosine of 2 theta. Oh, I don't know why my S just flew down there. Okay, cosine of 2 theta, there are 3 equivalent equations for it. So there's the cosine squared theta minus sine squared theta. It's the same thing as 1 minus 2 sine squared theta, and it's the same thing as 2 cosine squared theta minus 1. So all these 3 equations are the same, okay? They're all equal. They all equal cosine 2 theta. You can use either or any of those, whichever one works best. So there's 3 options for cosine 2 theta. So write down all of those. So I'll give you guys some time. I'll pause the video right now. All right, let's go on to the first section. So that's the double angles. Let's click on the double angles. Okay, assume that theta is a positive acute angle. Given sine of theta is 8/17, find cosine of 2 theta. So let me screenshot this. Okay, let me write out the formula for cosine 2 theta. Okay, remember that cosine 2 theta has 3 formulas, so I'm just going to write all 3 of them out. So the first formula would be cosine squared theta minus sine squared theta, and the second one would be 1 minus 2 sine squared theta, and the third one would be 2 cosine squared theta minus 1. Okay, and then they gave us sine theta right over here, right? This is given. Given is sine theta. Now looking at the 3 formulas that we could choose from, this one, the middle one, just uses the sine, okay? Because the first one uses cosine and sine, so we would have to look for cosine, which we can do. We can do it by, drawing the triangle, but, it's easier to have less work. The second formula only uses the sine, so that's less work already, and the third one uses cosine only. So the easiest one for us to use would be the second formula because it's only using sine. So let's use that second formula. I'm going to circle it. Okay, I'm going to write it on the side here because that's where I have more space. So now that we've chosen the 1 minus 2 sine squared theta formula, let's plug stuff in. Hold on. Okay, let's plug stuff in. So we have 1 minus 2, and then sine squared theta just means that we take the 8/17 and we square it. So that's what sine squared theta means. It just means take the sine and square it. Before I simplify this, are there any questions? I'll pause the video so that you guys have time to say something. Okay, so let's simplify this. We have 1 minus 2, and we're going to square it first because according to Pemdas, you do the exponents before you multiply it to the 2. So let's square the 8/17. So on the top, we just have 8 times 8, or 8 squared, which is 64. On the bottom, we have 17 times 17, which is 17 squared, and that is 289. We just need to simplify some more. Let me draw that down here so I don't get things mixed up. 1 minus, now we can multiply to the 2. When you multiply it, only multiply it to the top part, okay? So 2 times 64, 128 over 289. And then finally, let's change that 1 to a fraction with the same denominator. So instead of a 1, it's 289 over 289 minus the 128 over 289. So subtracting those, we'll get, where should I write my answer? I'll write it over here. 161 over 289. And that will be your final answer. So subtracting it straight across, 289 minus the 128 gave us 161. The denominator stays as 289. I'm going to pause it here to see if you guys have any questions. Okay, 161 over 289. Okay, cool. Let's do a few more examples of this. All right, so we have cosine 2 theta given a sine again. So once again, you just ask yourself, what are the 3 formulas for cosine? And so I'm going to write those 3 formulas out. You can either use the cosine squared theta minus sine squared theta, or you can use the 1 minus 2 sine squared theta, or you can use the 2 cosine squared theta minus 1. So all of these are equivalent formulas, and we get to choose which one we want to use based on whatever's easiest for us. They gave us sine. So if we were to use this first one, we would have to still, or I guess I'll use red still. If we were to use the first formula, we have our sine, so we can square that, but we would have to look for the cosine. I don't want to look for cosine because I'm lazy. I don't know about you, but I don't want to look for cosine. So I don't really feel like using the first one. Let's take a look at the second one. Oh, look, it just uses sine. That seems good. What about the third one? It just uses cosine. So I would still have to look for cosine for the third formula. So the first one and the third one use cosine. Let's not use that. Let's just do the second formula because the second one only has sine. So let me rewrite that second formula out. 1 minus 2 sine squared theta, and let's plug it in. So we have 1 minus 2, and then where the sine is, I'm just going to put what they gave us, 11 over 61. And don't forget it was sine squared, so I have to square this. So it's 11 over 61 squared. Now to simplify this, we have to do Pemdas. So that means we're going to square it before we multiply to the 2. Okay, so let's square it. 1 minus 2 times, and then on the top we have 11 squared, which is 121. On the bottom we have 61 squared, which is 61 times 61, 3721. Okay. And then we're going to multiply this by 2. Remember, when you're multiplying a fraction by something else, you just multiply to the top part. So 121 times 2 gives us 242 over the 3721. And I'm going to just draw a line here so we don't get mixed up. Okay. And then finally, we have our number 1 on the front. We're going to change that to a fraction that has the same denominator. So 3721 over 3721 minus 242 over 3721. And then when you subtract that, it gives you 3479 over 3721. And that will be your final answer. I'm going to pause it here to see if you guys have any questions. All right, so 3479 over 3721. 3479, 3721. 3479, 3721. 3479, 3721. Did I do that right? Yes, okay. All right, let's try to find one with something different, because we did just 2 examples where we want to find cosine of 2 theta and we were given a sine. So let's find some different examples. Okay, so this one wants to find sine of 2 theta. Perfect. So I'm going to screenshot this. And let's take a look at it. So what is the formula for sine of 2 theta? Let me write it out. Sine of 2 theta only has one formula, and that was 2 sine theta cosine theta. Okay, so for sine 2 theta, this is the only formula. We don't really have options here. We don't get to be as lazy as before, but we were given sine theta, okay? That's this one. So all we have to do is now look for cosine theta. And you probably guessed it, in order to find cosine theta, we are going to use the triangle. Okay, so let's go ahead and draw a triangle somewhere where we have space. I'll just draw my triangle over here. Oops, whatever, good enough. So here's my right triangle. We weren't given a letter, but we were given an angle. Oops, there we go. Okay, I'm gonna make theta this angle. So this is my reference angle. And according to SOHCAHTOA, sine is the opposite over hypotenuse. That's what the SOH stands for. So sine is opposite over hypotenuse. So that means the 28 is the opposite and the hypotenuse is 53. So I'm going to label that opposite side 28 and the hypotenuse I'm going to label 53. Then we are going to use, you probably guessed it, the Pythagorean theorem to solve for that missing side. So here's our A side, our B side, our C side. A and B can be switched as long as C is your hypotenuse. So let's plug it into our Pythagorean theorem to solve for our missing side. Okay, I just wanted to zoom out there. Okay, so we got our A squared plus the 28 squared equals 53 squared. Okay, and then solving for the A, we have 28 times 28, we have 784 equals 53 times 53, 2809. We're going to subtract that 784. Okay, so we got that A is 45. We put that over there as our missing side, which is great. So now that we have all three sides of our triangle labeled, we can now find the cosine, which is what we wanted earlier, right? So we want cosine of theta. So according to SOHCAHTOA, cosine stands for adjacent over hypotenuse. So that's what the CAH stands for. Cosine is adjacent over hypotenuse. So let's write out what our cosine theta would be. I'll write it over here. Cosine theta would be the adjacent side, so 45, over the hypotenuse, 53. So now we know what our sine is. It's given to us in red, and we know what our cosine is. We just found it in blue. So now we have enough information to plug into our original formula. So let's plug it in. So it's 2 sine theta cosine theta. So 2 sine theta cosine theta. And before I simplify, are there any questions up till here? I'm going to pause the video so you guys have time. All right, so we're continuing. We're just going to simplify. Let me multiply. You can multiply them in any order. I'm just going to choose to multiply our fractions first. So let me just multiply those two. So 28 times 45 on the top gives you 1,260. On the bottom, we have 53 times 53, which gives us 2,809. And then multiplying 2 times 1,260, 2 times 1,260 gives us 2,520 on the top, and on the bottom it stays the same, 2,809. And so this would be your final answer. Are there any questions? Give you guys 10 seconds. Okay, so let's go submit this. 2,520, 2,809. 2,520, 2,809. 2,520 over 2,809. I think I said that right. Okay, yes. So we did 2 examples of cosine. We did an example of sine. Um, I think we're good for now for this one. So let's do the next section.